Looking at the stars for thousands of years. Long ago, he saw that the stars formed patterns in the skies, patterns that he named out of his primitive imagination. Man has been looking at the skies for thousands and thousands of years. And in all his experience, and all the time he's lived upon the earth and watched these skies, I'm sure there has never been another spectacle so awe-inspiring, so filled with true grandeur. The patterns of the stars, those patterns that we call constellations, and that word simply means a grouping of stars, are made up, of course, of the various positions of the stars within them, and of their stars' varying brightness. Professional astronomers must all have started as amateurs who were never able to shake off the fascination of these skies and who kept on with that work throughout all their professional lives. In addition to the beauty that there is in the sky, there is also a large measure of utility there, for man has used the stars to guide him when he has traveled across the trackless wastes of deserts and oceans in navigation. And in recent years, we have been able to use the stars as vast laboratories, giving us conditions of temperature, for example, that we could never duplicate in any laboratory here on Earth. Thousands of years ago, man considered that the stars were tiny points of light fastened to the inside of a tremendous hollow sphere, and the Earth was in the middle of this sphere. Now, we know that isn't true. But in astronomy, we still use the convention of the celestial sphere, for that is what we call the sky as we see it over our heads. It's something like this. Here's a celestial sphere, you see, with the Earth inside it, turning and making the infinite variety of the skies as it does turn. We know that isn't true. We know that the stars in any given constellation are definitely not on the same plane, that is, not all at the same distance from us. The constellations are infinite in depth. And in most cases, the stars in any constellation which are bright to us are those which are near to us. And the fainter stars are the more distant ones, as in this picture, which is one taken through one of the great telescopes. Here are 4 pictures of the same part of the sky. And in this one, with the longest exposure, we can see this apparently tremendous bright star with a background of much dimmer stars. Actually, this star is bright principally because it's near to us. And there are probably many stars in that background which are really much brighter and much hotter than this one, but which are made faint by distance alone. We are going to try today in this program to give you an opportunity to look at the stars with some understanding of the constellations, how to find them. We're going to try to teach you something about using a star chart, for example, and perhaps a little bit about using a telescope. Now, it was, 2,000 years ago, I guess, more or less, that man first began to formalize the constellations, to give them names, and to roughly define their boundaries. The names of the constellations, incidentally, have been drawn from the vivid imaginations of very primitive people. I'm sure that all of us can recall the names of some of the more prominent and brighter constellations, such as the Greater Bear, for example. Now, we don't know whether the stars in this constellation were so named because they happened to look like a bear to these people, or whether they were named in memory of a bear which held a prominent place in the mythology of the people, or whether the name came down as a mistranslation of an earlier language and was adopted by these people. Actually, the constellations are areas in the sky, places. You might better consider them as states in a sort of a United States of the sky. They are used for locating objects which lie within the boundaries of the constellation, just as the states locate cities and towns within them, a city in New Jersey or Connecticut or Kansas or wherever. Most of the constellations are far too big to be photographed on any one photographic plate, so that to see what a constellation looks like, we have to turn to charts, and there are charts of all kinds, as we shall see in a little while. Actually, the easiest way, the most simple way, for you to find out about the stars and begin to get acquainted, a friend who knows his way around among them. In this program, I am going to be your friend. We shall go out together and look at the stars. But first, let's recall that the same stars are not visible in the sky at every night in the year. Now, here is why. Here we have made a representation of the sky, of the celestial sphere, or the celestial half-sphere, of course, which is what we can see from the Earth on any night. We not only have this much of stars, but all out here, too, is stars. It goes completely around us, over our head, from horizon to horizon. Now, where we are on the Earth, we can see, here is the sun, lighting up this side of the Earth. So, although there are stars here, beyond the sun, the overwhelming brilliance of the sun quenches out those stars. We just can't see them. However, if we get into the great cone of shadow of the Earth, which we call night, then we can see the stars. Now, as the Earth moves around the sun through the year, we can see that these stars are apparently going to move in the opposite direction, from east to west, because the Earth's motion is from west to east, and the stars will seem to slide by us here, slide by the Earth in this way, rising a little bit earlier, setting a little bit later every night, until finally the whole pattern will change. And as we go through the year, in the summertime, we shall find the stars that we were able to see in the night sky in the winter are now hidden beyond the sun, and we can't see them. And those stars which in the winter were behind the sun in the daytime are now on the dark side of the Earth, away from the sun, and are visible to us. This is the ever-changing pattern of the skies. Now, as we go out to look at the sky, we shall pick a night in late summer. It's a little bit more comfortable before it gets too cold. We shall also select a time when there isn't any moon, for the moon's light quenches the light of all but the very brightest of the stars. We try to find a place where there are not too many trees and houses to obscure our horizon, and we try to get at least 50 miles from any big city, so that the haze of city light and the dust that cities always throw up into the skies will not bother us. In order to begin our exploration of the skies, in fact, begin exploration of anything, you've got to have a starting point, a reference point. And we will try to find one which will always be available, no matter what time of the year or what night you go out. For our purposes, that starting point will be the North Star, the star called Polaris. Now, we're going to go out, but we've got to, where is north? Which way shall we look? Well, if your astronomical friend doesn't happen to know the north, it's easy for you to find if you want to try it alone. Take a compass. You don't have to be deadly accurate. Just give yourself a general idea of where north is. Now, let us go out then and take a look at the north and see what we can see. As we go out, and we shall face north for the moment, although that is astronomically unconventional, as we shall see, we shall face north. And high up to our left, or to the west, we will see 4 fairly bright stars that mark the corners of an irregular rectangle of stars. From the lower right-hand star, 3 more stars go down, forming a curved line in the sky. This group of 7 stars make up the very familiar figure of the Big Dipper. It is a part of the constellation of Ursa Major, the Greater Bear. The names of all the constellations are given in Latin, because Latin is the nearest thing that we have to a universal language. Astronomers come from all countries and speak all languages, but most of them have a smattering of Latin, enough to talk about the constellations anyway. These 7 stars make up then the figure that we call the Big Dipper. 4 stars make its bowl, 3 stars, its handle. Now let's consider these 2 stars, the stars that form the side of the bowl of the Dipper farthest from the handle. They seem to lay out a line in the sky to mark a direction. Let us follow that direction, and we shall go to our right about 5 times as far as the distance between these stars. And as we do, the first bright star we will come to, almost on that line, is the star we are looking for. This is our reference point. This is Polaris, the North Star. These 2 stars in the bowl of the Dipper have pointed the way to Polaris, and for that reason they are called the pointers. Polaris is the brightest star in the constellation of Ursa Minor, the smaller bear, and it is also the end star in the handle of the Little Dipper. Now here's where we're going to meet our first astronomical disillusionment. The stars that make up the Little Dipper are, many of them, very faint, and it is only under the most unusual circumstances that we are able to see the whole figure of the Little Dipper. Ordinarily, we can see Polaris, and we can see the 2 stars that form the front of the bowl of the Little Dipper. The Little Dipper, you see, is made up of 7 stars, 4 stars making the bowl of the Little Dipper, and 3 stars making its handle. These 2 stars, which are bright enough to be seen ordinarily, are called the guardians of the pole. Now, Ursa Minor is not a very big constellation, and its importance lies almost entirely in its location and in the fact that it does contain the North Star, Polaris, the prime navigational star. And Polaris, as we shall see in a few minutes, will always be there, and we can always use it as a starting point for our exploration. Now let's see how we can use it. Let us go back again to the Big Dipper, to these same 2 pointers, the stars that form the front of the Dipper's bowl. We'll follow that line, come to Polaris, the focal point of our exploration, and keep on going past it, just about as far to our right, or to the east in this case, as the Dipper is to the west. And we shall run into another group of stars which make roughly a rather crooked M-shaped figure in the sky. This is the constellation of Cassiopeia. At this time of the year, it does look something like a rough M. If we wait some months until the motion of the Earth around the sun has brought Cassiopeia around in the sky until it is where the Dipper is now, that M will look more like a W. And after all, a W is simply an M upside down anyway. Now, we have been looking to the north. And, of course, most of our sky is to the south. We shall turn our backs now on Polaris and look to the south. And as we do that, we shall find that the Big Dipper is then high over our right shoulder, and Cassiopeia high over our left shoulder. And the southern part of the sky lies before us there. Now we're going to back to the Dipper again and use this time the handle of the Dipper as our guide to our next star. That handle, you see, these 3 stars strike a curve in the sky. They form a part of the circumference of a circle. Now we'll continue on that curve past the last star in the handle, keep right on going, and on that same line, quite far to the south, we will run into a very bright, definitely red star. This is Arcturus, one of the most important stars in the sky. Arcturus is actually the 4th brightest star of all the stars that we can see from the Earth. And it is the 2nd brightest star that we can see from our position in the northern part of the Earth. Arcturus is the brightest star in the constellation of Boötes, the herdsman. Now, don't look for a man in this group of stars. Look for a kite such as might be flown by any small boy. And Arcturus will be at the place in this kite where the tail is usually fastened. Above Arcturus, the fainter stars draw your eye up to the much wider angle point at the top of the constellation of Arcturus. Now, we're not through yet. We can keep right on going. Follow the same curve, you see, down through Arcturus and down very close to the southern horizon, quite far to your west or to our right now that we are looking southward. We'll see another very bright and much whiter star than Arcturus. This is Spica. Spica is the brightest star in the rambling and rather faint constellation of Virgo, the maiden, whose fainter stars outline a roughly rectangular figure that lies east and west, almost on our southern horizon at this time of the year. Now, there is a little memory-jogging phrase which will help you to remember how to find these two new stars whose acquaintance we have just made. Remember the curve of the handle of the Big Dipper. It strikes out a portion of the circumference of a circle, the arc of a circle. All right, follow the arc to Arcturus and speed to Spica. And there you have it. Now, this is just a tiny sampling of the stars which can be seen at one time on one night of one season of the year. I hope it will give us a means of getting further acquainted. Remember that every clear night, all through the year, there are wonders to be seen up there, even without a telescope, just the stars and those constellations. Actually, there are 88 constellations which fill the entire celestial sphere without any vacancies whatever. Remember, too, this reference point of ours, Polaris. I told you that it would always be there, always be faithful and on the job and never move. And here again is the reason for that. Now notice that our Earth here, its pole is pointing in a given direction. And as the Earth turns and goes around the sun through the year, notice that the direction in which the pole of the Earth points does not change. Polaris is located in the sky almost directly above the North Pole of the Earth, as the motion of the Earth through the day makes the Earth spin upon its axis, moving the stars across the sky apparently from east to west during the night. The permanence of that pole keeps it pointing at Polaris, and Polaris does not move. Polaris you will find in the same place all night, every night, all through the year. You can use it very definitely as a starting place. Now, I told you that there were charts to enable you to find your way around the sky. There are a great many of them. Some of them are small and relatively simple and inexpensive, and most of them are good. Here is a typical star chart. The opening cut here will give you a sight of the sky as you see it on any given night at one time. Now, as time goes on, by turning the chart, you can see the stars wheeling across the chart as they wheel across the sky from left to right, from east to west. Now remember this, too, and you'll find one peculiarity about star charts. They are oriented differently from Earth maps or charts. When you are looking at a map of the Earth, you are on the outside looking in. North is at the top of the map, the east is at your right, and west is to your left. When you were looking at a chart of the sky, you were on the inside of this celestial sphere of ours looking out. North is still at the top, but east is at your left and west at your right, and the stars move across your sky from left to right, from east to west. Now, you will learn as you go along that the best way to use a star chart is to go out and hold it over your head and then look up and see what you see. Perhaps shine a flashlight on the chart. It may work, but if you do use a flashlight, it will take you about 10 minutes before your eyes get accustomed to the dark again and you can really see the stars. And if you do very much holding of the chart over your head, you'll learn why astronomy can become a pain in the neck. Now, there are elaborate star charts, much more elaborate ones. Here is one here. Quite a good one and quite a big one, and it has the same features. I'm just going to arrange it so that what the sky we just looked at a few minutes ago is up before us. And here it is. Here, for example, is Polaris, the North Star, right in the center, the focal point about which the whole sky seems to turn because the Earth turns about Polaris. Over here are the four stars that make the bowl of our Dipper, and here are the pointer stars. Here is the handle of the Dipper. Follow the arc to Arcturus and speed to Spica. You see that same curve goes right on around. Follow the pointers to Polaris, keep right on going, and here is our crooked M of Cassiopeia. And in this opening, as in the smaller chart, are the stars which we can see. from horizon to horizon at any one time and any one night. And as the Earth turns, turn the chart. Follow the stars across the sky. Meet the new ones rising in the east as the hours go by, and say farewell to the old ones setting in the west as time marches on. Now, we have drawn upon maps, upon globes of the Earth and on maps of the Earth, imaginary lines to help us to measure distances upon the Earth and to find our way about on it. On this little globe here, we see some of those principal lines. The most important one, perhaps, on the Earth is the equator, which goes right around the Earth, halfway between the North Pole and the South Pole. Parallel to the equator, there are other lines, and a few of them are shown here. These lines are parallel to the equator, are called latitude lines, and measure distance north of the equator to the North Pole and south of the equator to the South Pole. Crisscrossing these lines, there are other lines, a set of lines which converge at the poles of the Earth and which are widest apart at the Earth's equator. These are the longitude lines and help us to measure distance east and west. Now, on the Earth, an arbitrary starting point has been chosen for the measurement of longitude, and that, of course, is on one of these lines which passes through Greenwich, England. We have done very much the same thing in the sky, on charts of the sky. We have drawn lines up there, imaginary lines, of course, which correspond roughly, and in most cases, to the lines that we find on the Earth. We have the celestial equator, the equator of the sky, which goes right around the sky and lies midway between the celestial poles, which lie over the poles of the Earth. Parallel to the celestial equator, we have drawn lines which correspond to the latitude lines, but we don't call them latitude. In astronomy, these are called declination lines, and measure distance in north declination from the equator to the North Pole, the celestial equator, to the celestial pole, and south declination from the celestial equator to the South Pole. Crisscrossing these lines again, we have drawn other imaginary lines in the sky, which converge at the poles of the sky and are widest apart at the equator of the sky. These lines correspond to earthly longitude, but are not called longitude lines. They are called our lines of right ascension and measure distance east or west in the sky. And as in the case with the Earth, we have chosen an arbitrary starting point, a 0 point in the sky, to begin this east and west measurement. That point is the place where the sun seems to stand on the first day of spring, right over the equator, on the 0 line. Now, these lines are given on our charts here. You can see on this chart, where man has drawn by convention the lines of right ascension, which measure distance east and west. Here are some of the more prominent ones, and a finer division of this same system can be found around the edge of the chart. Here is the equator, the celestial equator, and here is the point where these two cross. And you can see indicated on this chart other lines of declination, measuring distance from the equator to the celestial pole and in both directions. Now, just as every city in the country can be located by its position where two of these lines, latitude or longitude, meet, so can every object in the sky be located from its position where two of these lines of right ascension or declination meet. And you can find them by consulting there. They're given on all charts, in all star catalogs. Now, what have we got so far? We have gone out and we have taken a look at the sky on a given night in autumn and had a very, very small glimpse of it. We have studied a chart. We have learned of the general motion of the stars and something of what they look like. Now, up to now, we have only used the equipment that nature gave us, just our two eyes. With a telescope, even a very small telescope, the wonders that you can see in the sky are magnified thousands of times. There are telescopes of all varieties, and frankly, the smallest telescope, which will give you any real satisfaction in looking at the sky, is one whose primary lens or mirror is at least 3 inches in diameter. This is a very popular type of telescope for the amateur. It has a mirror 6 inches in diameter, and it will give you a wonderful view of the sky. Most of the larger telescopes of this kind have apparatus upon them which will enable you to find objects by means of their coordinates, which you cannot see without a telescope. But there is another way of doing that, a way which will give you perhaps an even better working knowledge of the sky and the things you can see there. You use the chart. Now, you look at the chart and you will find the faint object you want to see fairly close, as a rule, to a bright star which you can easily see without a telescope. And go in and study the chart. And incidentally, that's the best way to do it, even if you're not looking through a telescope. Don't stand there with a chart over your head. Go in and look at it. Memorize a little bit of it and then come out again. Find your bright star. Find out where it is. Come out to your telescope. Now, there are a number of things you should know about your own individual telescope. How much of the sky can you see with the various eyepieces? What is your field of view? Your telescope should also have a finder, a small auxiliary telescope with a wide field of view, which will give you a picture of the same part of the sky with a much greater extent than your telescope. Find the bright star, remember, that is near to the faint object you want to see. Go out and point your telescope at that bright star. It won't be hard. It'll be right there. Then move the telescope in the direction and at the angle from you that that faint object is. Move it slowly, and you'll be looking through it at the same time. Don't miss that object, and don't miss the parade of wonders that will go across the field of view. If you're lucky, you may hit it. If not, sweep back and forth, raising the telescope a little bit between each sweep, so. And in a very few minutes, your object should slide into the field of view. Amateurs can perform very valuable service to professional astronomers, particularly in the field of the observation of variable stars. They can also observe comets, and many an amateur has gained fame through the discovery of a comet. The observation of meteors and meteor showers and of the aurora are all of great value to the professional and can be done by the amateur. In any event, there is the sky. Go out and look at it. The stars are there for you. And in all your life, you will never see a sight as awe-inspiring and as wonderful as the stars.
This is National Educational Television.